Hello, calculus fans. Okay, we've talked about the evaluation theorem, and that's actually what we're going to call part 2 of the fundamental theorem of calculus. Now, we introduced it first because it's actually used a lot more than part 1 of the fundamental theorem. So let's just finish this up by putting these two theorems together. So we start by saying that suppose that we have a continuous function on the interval from a to b. Then if g of x is the integral from a to x of f of t dt, then we can differentiate this function and get back to f of x. That's part 1 of the fundamental theorem. Part 2 of the fundamental theorem says that if we want to evaluate a definite integral, we can do so by subtracting f of b minus f of a. That's big F. And big F is any antiderivative of little f. So I'm going to stop calling this the evaluation theorem and just say that it's by the fundamental theorem of calculus. Now, the book gives a very careful proof of part 1 of the fundamental theorem, and it does so without assuming the existence of antiderivatives, which is important to do. Because part 1 of the fundamental theorem is essentially saying that antiderivatives do exist, so if you assume that they exist, then it sort of begs the question. Okay, that's all for now.